Welcome to our module on Python programming. Today, we'll dive into this incredibly powerful and versatile language. Python is truly versatile, widely used across STEM fields, data science, web development, and so much more. Before we start coding, let's walk through the essential stages of installing Python software on your system. The installation process is generally straightforward, designed to work smoothly across various operating systems. First, you'll need to download the official Python installer package from the Python website to begin. Next, you'll run the installation wizard, following the on-screen prompts carefully to configure Python. Finally, it's crucial to verify your installation to ensure Python is correctly set up and ready to use. Now, let's explore how to install Python specifically on different operating systems, like Windows, macOS, and Linux. We'll cover the specific commands and steps required for each platform to ensure a successful installation. To verify if Python is already installed on your Windows machine, you can simply open your command prompt. Type Python version into your command prompt. This command will display the installed Python version. For macOS users, a popular and efficient way to install Python is by utilizing the Homebrew Package Manager. With Homebrew installed, execute brew install Python 3 in your terminal to get the latest Python version. On Ubuntu or Debian-based Linux systems, you can easily install Python using their built-in package manager. Run sudo apt update to refresh your package list, then sudo apt install Python 3 to install Python. For Fedora users, Python installation is also straightforward, leveraging the DNF package manager. Simply use the command sudo dnf, install Python 3 in your terminal to install Python on Fedora. Let's now explore Python packages and virtual environments, crucial for managing your project dependencies effectively. These tools are essential for keeping your project dependencies organized and avoiding version conflicts. First, let's look at installing packages using pip, Python's standard package installer for external libraries. The pip command is Python's package installer. Use pip install for new libraries, pip list to see what's installed. These commands demonstrate installing NumPy, upgrading pip itself, and listing all your installed packages. Next, we'll learn how to create a virtual environment, which is vital for isolating your project's dependencies. A virtual environment isolates your project's Python setup, preventing dependency conflicts using the Python mvenv command. This command creates a new virtual environment named myenv, providing an isolated space for your project. After creating your virtual environment, the next crucial step is to activate it for your project. Activating the environment allows you to use its isolated packages, and the specific command differs by operating system. Here are the activation commands for Windows, where you specify the script, and for macOS/Linux using source. Today, we're diving into Python, a powerful and versatile programming language that's widely used across many fields. We'll explore some essential concepts that are fundamental for writing clear, readable, and efficient Python code. First, let's talk about keywords. These are reserved words with predefined meanings in Python. For example, def is used to define functions, and if is for conditional statements, each having a special role. Next, we have identifiers. These are the names you give to various elements in your code. Identifiers name variables, functions, and objects, and you must follow specific naming rules for them. Then there are comments, which are incredibly important for code readability and understanding. Comments are non-executable notes that you add to your code to make it easier to understand for yourself and others. Indentation is a unique and crucial aspect of Python syntax that defines code blocks. These spaces at the beginning of a line are not just for aesthetics, they are essential for defining code structure. Finally, let's look at statements, the core commands that your Python program executes. Statements are commands the interpreter executes, ranging from simple expressions to complex control flow structures in your program. Welcome back to our Python journey. Today, we're exploring how Python handles different kinds of data. Python offers several categories of data types, each designed for storing and managing diverse data efficiently. First up, we have numeric types, which are fundamental for any mathematical computation. This category includes integers for whole numbers, floats for decimals, and complex numbers for advanced math. Next, we have sequence types, which are ordered collections of items that can be accessed by their position. Strings, lists, and tuples are examples, allowing you to store and retrieve data using an index. Then there are set types, which are unique collections where each element appears only once. These unordered collections are perfect for ensuring uniqueness and performing quick membership checks. The mapping type is incredibly useful for storing data in a highly organized and accessible way. Dictionaries are the primary mapping type, storing data as key-value pairs for very efficient data retrieval. Boolean type is essential for logic and decision-making in your programs. It represents truth values, meaning a variable can only be either true or false. Finally, binary types are used when you need to work directly with raw binary data. These types, like bytes and byte arrays, are crucial for handling low-level binary information effectively. Let's explore the essential steps involved in Python's file handling process, which is crucial for data persistence. The very first step is to open a file, which establishes a connection between your program and the file. Next, you must specify the mode, indicating whether you intend to read, write, or append to the file. Once open, you can read data from the file, bringing its contents into your program for processing. Alternatively, you can write new data to the file, saving information from your program onto your disk. If you need to add to an existing file without overwriting, you'll choose to append new data. Finally, and very importantly, always remember to close the file to release system resources and save changes. Today, we'll cover essential operators and understand how to control the flow of your Python programs. These concepts are fundamental for directing the logic and performing calculations within your Python scripts effectively. First, let's examine Python operators, which are special symbols that perform operations on values and variables. Arithmetic operators like plus, minus, multiply, and divide perform standard mathematical calculations in your code. Comparison operators, such as equal to or greater than, are used to compare two values and return a Boolean result. Logical operators like and, or, and not allow you to combine or negate conditional expressions. Assignment operators, like the equal sign, are used to assign values to variables efficiently. Now, let's move on to control flow, which dictates the order in which your program statements are executed. Conditional statements, using if, elif, and else, allow your program to make decisions and execute specific code blocks. The for loop is used for iteration, allowing you to repeatedly execute a block of code for each item in a sequence. A while loop, on the other hand, repeatedly executes a block of code as long as a specified condition remains true. Finally, loop control statements like break allow you to exit a loop early, while continue skips the current iteration. All right, let's do a quick recap of the Python basics we've covered, reinforcing these fundamental concepts for you. These are the key takeaways, essential points that will guide you effectively throughout your Python programming journey. Remember, installing Python is your very first step, often requiring specific commands based on your operating system. We learned that pip is crucial for managing packages, and virtual environments help isolate your project dependencies efficiently. Python's core syntax is built upon keywords, identifiers, comments, indentation, and various statements that define your code. Python offers diverse data types and powerful built-in structures like lists, tuples, sets, and dictionaries for organizing data. File input/output involves the crucial steps of opening, performing operations, and always securely closing your files afterward. Operators enable computations and comparisons, while control flow statements are essential for directing your program's execution path.